The Sunray Venus clam, Macrocalista nimbosa, noted for its radiating shell pattern, is of commercial interest in Florida and the southeastern United States due to its high dollar value and popularity among consumers. Florida Sea Grant-funded studies conducted in the late 2000s showed that Sunray Venus larvae and poset could be raised like the hard clam Mercenaria mercenaria. Basic Sunray larval culture information was shared in a video produced in 2009. This video provides results of recent research, examining effects of temperature, diet, and drain-down frequency on larval and post-set sunray production. Results are based on Florida Sea Grant-funded experiments conducted at the Florida Atlantic University Bivalve Research Hatchery from 2018 to 2022. In a companion video on Sunray Venus maturation, results of experiments examining effects of water temperature, feed rate, conditioning time and season on spawning rate, egg production, fertilization success, and D-stage development were summarized. The following 4 tables show how changes in maturation conditions continue to influence survival beyond D-stage. Tables 1 and 2 show the effects of conditioning temperature and feed rate. Conditioning temperatures above 64 degrees Fahrenheit and feed rates of 6% or higher resulted in increased development to D-stage and survival to 1 millimeter. At 70 degrees Fahrenheit, survival to D-stage was 59%, and to post-set it was 50%. At a feed rate of 6%, survival to D-stage was 64%, and to post-set it was 46%. Tables 3 and 4 show the effects of conditioning season and time. SRV broodstock conditioned during winter resulted in a high spawn rate of 50%, but survival to D-stage in post-set was low at 33 and 38%. In comparison, D-stage development was 44 to 71%, and survival to post-set was 68 to 75% during the spring, summer, and fall. 9 weeks of conditioning resulted in a higher D-stage development of 72% and survival to post-set of 77% compared to 6 weeks. Additional conditioning time of 12 weeks did not enhance production. The recommended conditions to ensure spawning success of Sunray Venus broodstock outlined in the maturation video are the same for increased seed production through a 1 millimeter sieve size. These recommendations include a minimum of 9 weeks of conditioning during the spring through fall seasons at a temperature of 70 degrees Fahrenheit and a feed rate of 6% or higher. Table 5 summarizes what a hatchery operator may expect in terms of spawn rate, fertilization success, and survival to 1 millimeter seed based on these recommendations. Following a successful spawn, one can expect an 84% fertilization rate, with 61% developing to D-stage, a 64% survival to post-set, and 38% survival to 1 millimeter. The effects of 3 diets were evaluated at the suggested conditioning recommendations. 36 broodstock clams were fed either a Cattosaurus neogracil diet, Isochrysis lutea diet, or mixed diet, consisting of equal amounts of Cattosaurus and Isochrysis, and spawned at 9 weeks using thermal induction. If spawning was not successful after a 2-day attempt at 9 weeks, spawns were attempted again at 12 weeks. For each spawning attempt, 3 hot and cold cycles of 1 hour each were used, with gradual temperature changes between 71 and 88 degrees Fahrenheit. All SRV clams spawn during the heat phase. Table 6 shows that best production occurred with the combination diet, resulting in a survival of 56% from egg to post-set, whereas broodstock fed the Isochrysis-only diet had the poorest survival at 42%. These results agree with other reported studies that show increased production when bivalves are fed multiple species of microalgae. A mixture of flagellates and diatoms creates a balanced nutritional profile compared to a monospecies diet, particularly with regards to fatty acid content, which affects egg quality. This in turn can result in increased D-stage development, larval survival, and post-set production. The typical larval rearing process for sunrays does not differ from that used for hard clams. Eggs are collected, pooled, fertilized with sperm at a 100-to-1 ratio, and sieved through a 20-micron screen to remove debris. Following assessment of fertilization, eggs are stocked into larval rearing tanks filled with UV-treated 1-micron filtered seawater, preheated to 82 degrees Fahrenheit. Tanks are lightly aerated, and Isochrysis lutea added at a rate of 25 to 50,000 algal cells per mil. At 24 hours, a 100% water change is conducted by draining the larvae onto a 20-micron screen. Following an initial assessment of D-stage development, the larvae are transferred to a clean, pre-filled and preheated tank. This process is repeated daily on screens of increasing mesh size until metamorphosis is reached, which is approximately 7 days for sunrays. An experiment was conducted to assess the effects of both temperature and drain-down frequency on sunray venus larval survival. Larval tank temperatures were set at either 77 or 82 degrees Fahrenheit, with drain-downs conducted daily or on alternate days. As Table 7 shows, there was no significant difference in larval survival, whether drain-downs were conducted daily or on alternate days. However, development of fertilized eggs to D-stage was significantly increased at 82 degrees Fahrenheit, with survivals of 63 to 71% obtained, as compared to survivals of 44 to 56% obtained at 77 degrees Fahrenheit. Survival to post-set at 82 degrees Fahrenheit was also higher, at 36 to 40%, compared to 7 to 9% at 77 degrees. Based on this study, it is suggested that larval tank temperature be maintained at 82 degrees Fahrenheit. Further, time and labor costs may be saved by conducting drain-downs on alternate days. Once clams undergo metamorphosis and reach petavelliger stage, they are called post-set and are transferred from larval rearing tanks to downwellers. Downwellers are used as setting containers. A fine mesh screen is attached to the bottom of the container, and an airlift is used to create a downwelling action. At this point, clams are typically fed a mixed diet of flagellates, such as Isochrysis, and diatoms, such as Cattosaurus. 2 post-set dietary studies were conducted for a period of 6 weeks. The first evaluated the effects of feeding various combinations of flagellates and diatoms. The second compared the effects of complete or partial replacement of live microalgae diets with a commercially available concentrate diet. Table 8 shows the 6 dietary combinations that were compared. As shown in Figure 1, growth was higher in dietary treatments containing 3 or more types of microalgae, and was highest when sunray post-set were fed 2 flagellate and 2 diatom species. Growth was lowest in clams fed the diatom-only diet. However, as shown in Figure 2, sunray survival was highest in clams fed a combination of Cattosaurus neogracil and Isochrysis lutea. Survival was lowest in clams fed the diatom-only diet. In this experiment, diets that resulted in highest growth did not necessarily result in highest survival. Still, the diets that contained both flagellates and diatoms resulted in better production when considering both growth and survival. The poorest performing diet in terms of both growth and survival was the diatom-only diet. Thus, a diet containing both flagellates and diatoms, preferably in equal proportions is recommended for Sunray post-set culture. Table 9 shows the live and concentrate dietary combinations that were compared. Production, as seen in figures 3 and 4, was highest in Sunrays fed a live microalgae diet and lowest in clams fed a complete replacement diet. Although survival was high in both partial replacement diets, clams were smaller than those fed a live microalgae diet. Survival and growth of clams fed the complete replacement diets were 50% lower than that of clams fed the live microalgae diet. Commercially available concentrates can successfully be used during times of inadequate microalgae production, but completely replacing a live microalgae diet is not recommended for Sunray post-set culture. We have previously pointed out differences in conditioning necessary for successful spawning of sunrays compared to hard clams. However, we have found that hatchery larval practices used for hard clams works well for sunray larvae. Sunrays typically undergo metamorphosis to post-set a few days earlier than hard clams, but they do not require additional care from hatchery personnel. We have, however, noted that Sunray post-set consume more microalgae than hard clams. Whether this is due to actual feed consumption or that the microalgae may be caught up in the copious amount of mucus they produce is unclear. This same phenomenon has also been noted in broodstock conditioning systems. This research was supported by the Florida Sea Grant College program and was a joint collaboration between FAU and UF. A copy of the full report, Building Hatchery Capacity of Production of a Promising Shellfish Aquaculture Species, the Sunray Venus clam, can be found at the following website.